Good morning, everyone. Myself, Kishan Shinde, currently pursuing my 7th sem in engineering in Sri Venkateshwara College of Engineering in the domain of computer science with artificial intelligence. So, today's topic is implementation and demonstrate Q learning algorithm. Come on, let's dive deep into this topic and let's explore what is meant by Q learning algorithm. Introduction. Reinforcement learning is an interdisciplinary area of machine learning and optimal control concerned with how an intelligent agent ought to take action in dynamic environment in order to maximize the cumulative reward. Basic components required are agent, environment, actions, and rewards. Reinforcement learning model has four essential components of one that is a policy, two that is a reward, and a value function and an environmental model. So what this means is that reinforcement learning is a type of a learning that comes under machine learning where optimal control concerns are taken place, which means that there is an agent which enacts and have its actions according to the environment and gets an reward if it's a correct thing that correct action is being performed, then it gets a reward. If a wrong action is performed, then it doesn't get a reward. And this way the learning keeps on going on in machine learning. This is known as reinforcement learning. Q-learning overview. Explanation of Q-learning as a value-based reinforcement learning algorithm. Q-learning is a model-free, off-policy reinforcement learning that will find the best course of action given to the current state of an agent. Use of Q values to iteratively improve the behavior of the agent. Q-learning uses Q values to represent the expected cumulative rewards of taking a particular action in particular state. What this means that it is an off-policy reinforcement learning. So it is not exactly an reinforcement learning. It is like an off-policy, which means that it is it is a learning reinforcement learning where the set of rules is not the same here. So it is as it says, it is model free, where in case of that isn't the matter. So here it says that if it finds a best course of action given at the current state of agent, at that exact point, whatever the best course of action could be performed, that would be performed by that agent. And iteratively, the rewards as soon as it gets a rewards, the behavior is being improved. What is Q table? Building a table of Q, that is S and A parameters parameter values. The Q table is a lookup table where we calculate the maximum expected rewards, future rewards for action at each state. Initialization and update of Q values based on agent's experience. To learn each value of Q table, we use Q learning algorithm, which involves an iterative process of updating the values based on agent's experience. So it calculates what is the maximum expected future rewards on the action that takes place at each state and each time. So at that exact time, whatever the best action that could be taken is being taken to expect the maximum future rewards. So this is being calculated via Q table. Just as it mentions here, initialization and update of Q values are based on agent's experience. Whatever the experience that if it gets a reward, it would be calculated as plus something, and if it doesn't get a reward, then it would be calculated as minus something. So this something is depends on the problem from each problem to another problem. So where the something would be S and A values as a variables that is being given here. So basic Q learning algorithm. Description of key steps in Q algorithm. Q learning is a model free reinforcement learning to learn the values of the action in a particular state. It does not require a model of an environment and can handle problems with stochastic transition and rewards without requiring an adoption. Exploration and exploitation phase. Q-learning algorithm involves a balance between exploration, trying new action, and exploitation, choosing actions based on current knowledge to find the optimal policy. So there is a two phases in this algorithm, that is exploration and exploitation. So exploration is a phase where it tries out new things according to the environment and might get a reward or might not get a reward also here in this phase. Where in exploitation phase, it choose the action based on the past experience or current knowledge, past knowledge or current knowledge, and try to get a optimal value. But the situation might not be same. So it might again it might get a reward or it might not get a reward. So this is the basic Q learning algorithm. Off policy learning. Explanation of Q learning as an off policy algorithm. Q learning takes an off policy approach to reinforcement learning, aiming to determine the optimal action based on its current state. The agent's ability to learn Q values regardless to the policy being followed. The Q learning allows the agent to learn Q values independently of the policy being followed, which contributes to its robustness and flexibility. Q learning example. Step by step illustration of Q learning process is a simple environment. A Q learning example can demonstrate how an agent learns to make decisions based on the Q values associated with different action of various states. Initialization, action selection, and Q values updates. Q learning process involves initializing the Q table, selecting the actions, and updating the Q values based on the rewards received. As I just said, the Q learning process is a simple initialization, action selection, and Q value update process where it selects the Q initialize the Q table and selects the actions to be performed according to the environment and update the values based on the rewards it receives. Convergence and optimality. Discussion on convergence of Q learning. Q learning aims to converge an optimal policy by iteratively updating Q values based on the agent's experience and rewards received. Goal of maximizing the Q value to find optimal action selection policy. The ultimate objective of Q learning is to maximize the Q value of each state action pair to determine the optimal action selection policy. Application of Q learning. Real world applications of Q learning, such as game playing and robotic control. Q learning has been successfully applied in various real world problems, including games playing, robotic controls, and optimizing tasks. Success stories and challenges are in applying Q learning to the complex program. While Q learning has shown success in many domains, it also prevents challenges such as scalability to the large state spaces and complex environment. Thank you. I hope you would have understood the gist of a topic on this given topic, that is Q learning algorithm. And I hope you give a like, share, and subscribe to my channel. Thank you.